The nation of Israel lives in a state of permanent conflict that seems to have no end in sight, as evidenced by the recent offensive that struck crucial points in its military infrastructure. Extremely important facilities such as the Nevatim and Tel bases, Nofiwat, which houses the sophisticated and very expensive F-35 fighter jets, was hit by high-precision bombing, as were the Hatzarim base and the Mossad headquarters in the capital. But before we begin, don't forget to like and subscribe to our channel. The central point of this Iranian offensive, considered the largest in history against Israeli territory, was the use of technological weapons such as the Shahab-3 missiles and the hypersonic Fatah missile. This raises the question of how Israel's robust air defense network, including the Arrow 3 system, failed to prevent these projectiles from reaching their targets. Strategic intelligence indicates that the 180 missiles were launched from a region near Shiraz, Iran, traveling a distance of over 1,600 kilometers across diverse terrain before impact. Among the weapons used, the Shahab-3 stood out. This medium-range missile uses liquid fuel and has the capacity to carry warheads weighing between 760 and 1,200 kilograms. Although its technical origin dates back to North Korea, the model was refined by Iranian specialists to ensure greater effectiveness and range. The launch process involves positioning the device vertically at a 90-degree angle, allowing for an optimized launch trajectory into space before proceeding to the target. After launch, the missile follows a path that takes it out of the Earth's atmosphere, where air resistance is lower and it can reach higher speeds. Upon reaching the desired altitude, the warhead separates from the main body of the rocket, beginning its return journey to Earth. Depending on the version, the missile may carry one or multiple warheads. These warheads re-enter the atmosphere and descend at hypersonic speeds toward the target, sometimes maneuvering to evade defenses. But this was not the only missile that hit Israeli territory. The Fatah-2, the latest evolution in Iranian missile technology, equipped with a hypersonic glide vehicle, was also used. This missile can maneuver at speeds between Mach 5 and Mach 10. Although its range is 1,500 kilometers, its evasive capability makes it especially dangerous. What differentiates the Fatah-2 from other ballistic missiles is its ability to accelerate out of the atmosphere and then re-enter, avoiding interception by the renowned anti-missile defense system, Israel's exo-atmospheric spacecraft, Arrow 3. Furthermore, their aerodynamic control surfaces allow them to alter their trajectory mid-flight, which greatly hinders detection and interception efforts. Hypersonic missiles are a relatively new but extremely challenging technology due to their very high speeds. To understand their impact, consider that if Russia were to launch such a missile, it could reach the United States in just 18 minutes. China, for example, with the development of the Dongfeng 17, is already part of the exclusive list of countries with this technology. Its hypersonic glide vehicle became one of the first to enter mass production with the capacity to carry conventional and nuclear warheads, becoming a nightmare for missile defense systems, especially for the United States Navy. It is no longer a secret that China possesses full-size replicas of American aircraft carriers in the Taklamakan Desert, used for live-fire training. In turn, the United States, although not as advanced, has also developed the AGM-183 ARRW, an air-launched hypersonic missile. When activated, it separates from its fairing and uses only the kinetic energy of its glider vehicle to hit the target, meaning it does not carry explosives inside. The United States claims that this approach maximizes speed and reduces the chances of detection. And of course, we can't forget Russia, which also demonstrated its capabilities with the feared Kinzhal, a hypersonic missile that, according to reports, has already been tested in Ukraine and reaches an impressive speed of Mach 10. That said, for a missile to be considered hypersonic, it must meet three essential criteria: a speed equal to or greater than Mach 5, maneuverability in flight, and extreme precision. But before we delve into how Iran's missiles managed to bypass Israel's air defenses, it's essential to understand the workings of Arrow 3, the missile defense shield in which Israel has placed its trust. The system consists of three key elements: the missile launcher, the Green Pine radar, and the Arrow missile. The launcher is an imposing structure mounted on the back of a two-axle trailer, equipped with 6 launch tubes. These tubes house missiles ready to be fired in a matter of seconds. When fully loaded, this system weighs approximately 35 tons. The Green Pine radar is the system's watchful eye. Strategically positioned, it scans the horizon for threats. This advanced radar not only detects ballistic missiles at long distances, but also calculates their trajectory and speed, providing critical data to the fire control system. Now, let's move on to the Arrow 3. This missile operates in 2 stages. At the base, we find the solid propellant of the rocket engine. These engines use a carefully formulated mixture of fuel and oxidizer, known as solid propellant. This substance, stored in a robust structure, is responsible for generating the energy needed to propel the missile beyond Earth's atmosphere. At the top of the rocket is the ignition chamber. When activated, it initiates a chemical reaction that releases hot gases under high pressure, propelling the missile to impressive speeds. To give you an idea, the heat generated is enough to melt steel, but thanks to advanced materials and cooling systems, the missile maintains its structural integrity. Moving to the front, we find the interceptor vehicle, the true brain of the operation. This component is divided into 3 main sections. First, the propulsion system, equipped with a thrust vectoring nozzle, which allows adjusting the missile's direction in mid-flight, ensuring maneuverability to intercept targets moving at hypersonic speeds. Second, the warhead. Contrary to what one might imagine, the Arrow 3 does not use a conventional explosive warhead. Instead, it employs the kinetic impact method, meaning it destroys the target through a direct collision at extremely high speed. However, in some models, there is a precision explosive charge of approximately 150 kilograms, designed to fragment and increase the chances of neutralizing the threat. And third, the Seeker. Equipped with infrared sensors and advanced guidance systems, it can detect and track targets in space, adjusting its trajectory in real time and differentiating real targets from decoys. 3 system is its ability to correct inaccuracies in radar detection. Imagine that the radar identifies a threat but cannot determine its exact position. In these cases, the interceptor adjusts its trajectory in real time, increasing the chances of neutralization. This is essential when dealing with intercontinental ballistic missiles traveling at hypersonic speeds. If the interceptor fails to recalibrate its course based on more precise data provided by its sensors, the result could be a critical interception failure. The Arrow 3 was only the first layer of defense against Iranian attacks and was considered the most effective. However, there are 2 other layers. The second is David's system, the Sling, designed to intercept medium-range missiles and drones. The third is the Iron Dome, famous for intercepting most short-range rockets launched against Israel, with a range of approximately 65 kilometers. Despite all this cutting-edge technology, Iranian missiles managed to penetrate all these layers of defense. How was this possible? According to reports, Iran launched 180 ballistic missiles, some possibly hypersonic, as stated by the Iranian Revolutionary Guard. Although the Arrow system intercepted many of them before they entered Israeli airspace, several managed to escape. The main problem lies in the nature of glider vehicles, such as those used in Fatah II missiles. After separation from the launcher, these vehicles can perform unpredictable maneuvers, altering their trajectory several times during flight. This capability confuses radar systems and interceptors, which are designed to handle more predictable trajectories. David's technologies. The Sling and Iron Dome missiles proved insufficient against the high maneuverability and speed of the hypersonic missiles. This technical limitation prevented the projectiles from being neutralized, allowing several of them to hit strategic military complexes housing F-35 aircraft, each worth over $100 million. Beyond the material damage, the financial impact of a single day of combat on this scale is alarming. While the Iranian government invested around $200 million to carry out the attack with drones and ballistic missiles, the defensive response from Israeli forces required an amount close to $1 billion. This difference is due to the high cost of the interception systems. The Arrow missile is valued at $2.5 million per unit. The David Sling costs $1 million, and shots from the Iron Dome range from $20,000 to $100,000. In contrast, Iran's offensive arsenal is much cheaper, with missiles costing around $200,000 and drones that can cost as little as $2,000. Faced with this enormous economic inequality in the war of attrition, Israel has directed significant resources toward the development of Iron Beam, a laser-based defense system that promises to reduce the cost of each interception to negligible amounts, around $350. Here's a video in case you're interested. See you next time.